Okay, we're going to continue on looking at MySQL as a programming language. This part two, we're going to look at particular statements, procedural statements that we can use in MySQL. So let's talk about our program structure. Program control statements like loops, ifs, and cases must be in a begin-end block. The begin-end block is going to start and end our function or our procedure or our trigger, whatever. A begin-end block must be in a function, procedure, or trigger. You can't just have a begin-end just floating nebulously. It's got to be part of it. This shouldn't strike you as odd being used to Java. This is just like you don't just suddenly have empty braces, right? You have a class or you have a method, and then you have your begin-end, which are your open and close braces. This is similar to that. There are examples in Cronky that confused me to no end, where he seemed to have just a little whack of code just floating by itself in the middle of things. As far as I can tell, that does not work. Each begin-end block can have its own set of local variables, right? Which shouldn't surprise us. We're used to, say, in Java, having a method or a class that has its own set of variables. And functions, procedures, and triggers can have parameters, but this varies by type. There are ways to pass information in, not so much triggers, but they vary by type, and we'll look at those at some point. But right now I'm going to focus on what's common to everything. So program output. We're used to, in a language like Java or even PHP, being able to print something. Yes, in PHP it's a little weird, it's called echo, but we print something. Also PHP, it goes to a web page. It's a little weird, but we're used to a program like in something like Java where we can print stuff. In this procedural MySQL, there's no print statement. Okay, you can do a select without a from or a where clause, and you can use that as a print substitute in procedures but not functions. If you're in a function, there's just no way to print something out. But in a procedure, you can say something like this example: select, quote, hello world, and it'll print out hello world to the screen. You're like, that's only so interesting. But if you have a local variable, you can print the value of the local variable. You can, let's say I have a variable called x. I can say select x, it'll print x to the screen. That can be helpful for debugging. It's not something we really want the end user to see, and that's really not the way this stuff works. Okay? Now, user-defined variables. These are like global variables. They're not the variables that we put inside the function or the procedure. They're variables that we use outside the function procedure. And I'll make a little demo of this. It's not going to work well at the PowerPoint, but I'll make a little demo of this. But for instance, if we're in PHP MyAdmin and we want to call a function and we want to put the results of that function into a variable, this is the kind of variable we would have. And you have to remember this is all multi-user, so maybe you're calling the function from PHP MyAdmin and I'm calling the same function from PHP MyAdmin. We want different results, and I want to get my results, you want to get your results, okay? So we have a separate set of variables for each database connection or each database client. This allows us to store a result from one statement and use it in another. Probably get it from a function or procedure, use it in different function or procedure. These variables can be int, decimal, that's base 10, floating point, binary, or character, and they're identified by an @ sign. So for it, here's an example. I'm going to declare a variable, initialize it to a value, and then print it out. So I can say set at test1 equals to tick ABC tick. Right, so this creates a variable, happens to be a string with the characters A, B, and C in it. It's called test1, and then I can say select at test1, and it'll print out A, B, and C. Okay, within a function, we can declare local variables. These have to be the first statement in a begin-end block. The declare order we have to have, there's a particular order we have to declare them in. We declare simple variables, then conditions, then cursors, which we'll get to in handlers. We won't really talk about conditions. So here are a couple of examples. I can declare x as an int. I can declare x as an int with a default value of 7. Okay. I can use the declare. I can also use the keyword set. That initializes it. You'll notice my declares only create the variable. They don't initialize it. You're like, well, this default thing kind of initializes it. I agree, that's confusing. I think this is designed by committee. So then we have a keyword called set that both creates a variable and puts an initial value in it. I can say set x equals to 8. I can also do something clever like say set x equal to x plus 1. Now, of course, I have to have already gotten an initial value into x or it's going to be confused, but these two statements will work together. I can say set x equals to 8 and then set x equals to x plus 1. And of course, if I were to print x at this point, x would have the value of 9. Okay, how do I get a value in there? We've talked about how select can be used as sort of a not very good print statement, but how do we get a value in there to begin with? We have something called select into, and select into reads from a table and places the values read directly into variables instead of returning a result set. Now, for this to work, if you think about it, our variables are simple variables. If we do a select that gives us like a whole set of multiple rows, I'm not going to have room for everything. So we have to design our selects so that we only select a single row, typically by using a where clause. So here's an example. I have variables called I1, I2, I3, and I4. They happen to be integers. And a variable called average, which is, these are all of type int. And then I do a select, and I do a select onto things called mark 1, mark 2, mark 3, mark 4. Those are presumably columns. I have columns called mark 1, 2, 3, and 4. And I say select into I1, I2, I3, and I4 from some table where going for some condition, doesn't matter what condition. The point is, I'm picking a condition where I'm confident that I will only get one row back, and that one row will show up in mark 1, 2, 3, and 4, and I will put it into I1, 2, 3, and 4, and that means I could now do arithmetic using I1, 2, 3, and 4. For instance, I don't know why I didn't make it onto this slide. I could sum I1, 2, 3, and 4 and divide by 4 and put that into average and come up with the average of the 4 columns. Now you may be saying, yeah, but I thought I could do that in SQL. Actually, you can, right? You can do an average and you can do arithmetic. So this is probably only yay helpful. Okay, we have an if statement. It's used for branching, and you need to be careful about making a comparison with a null value. We get stuff out of the database, and we could end up with a null value. And we have to be careful about saying some things with that. And we don't use a begin and end here. We use if followed by then else, and in end, the end matches the else matches on the then. So I say if x is greater than 10, then I have this poor print statement where I say that x is large, else I have the select that says that x is small. Now, if x has gotten a null value, is null greater than or less than 10? It's kind of tricky. You don't really want to go there. You want to be careful about that. Okay, so here's a while loop, right? Now, so far, we haven't needed a lot of loops working with SQL. Why? Because most of the looping action takes place under the covers. You select on a table looking for a particular value, like everyone, all the customers in Georgia. Somewhere down at the machine level, there's a loop, but we don't have to see it. The select just takes care of all that for us and says, oh, here's the set of things that match your criteria. But this is if we want to dig in there and use a loop, which in general we don't, but sometimes we have to. So here we have a while loop. It works just as you would guess this while loop would do. While x is less than 10, do, and the code that gets executed if x is less than 10 is everything between the do and the end while. Okay, in this case, I'm using it to count, right? I'm going to set x to x plus 1, and I'll go through this 10 times. So at the end of this, x will be whatever the original value of x was, plus I've added 1 to it 10 times, okay? Okay, here's a concept we have to get our head around. We've been mentioning that SQL likes to work with sets. We've seen that. The natural thing for SQL to do is to start with a set. Ultimately, that set's also a table, and it massages the set and it returns a set. It might only have one row in it, but it's still, from SQL's perspective, it's a set. It's just a set that happens to have one row. Then we've got this procedural code with ifs and whiles and simple variables, and somehow we have to transition between these two worlds. And the way we do that is with something called a cursor. Okay, a cursor is used to feed database table information into the procedural level of code. A cursor retrieves a set of information, and the procedural code then loops through the set a row at a time, doing whatever it needs to do with it. You can think of cursors as being somewhat like a file where you open the file and you do a read. Well, do you get the whole file? Well, typically not. You typically get a piece of the file, like a line of the file. If we think of a text file, we open the text file and we have a loop, and the loop reads line after line after line. In this, we open the cursor and we call a statement called fetch, and this fetch gives us back a single row, and then we call that fetch over and over and over again until eventually we run out of rows, and then we close the cursor. Okay? And if you think about it, we see something like this in PHP. In PHP, we executed our select, right? And we got back a set, and then we had to have a loop to loop through it that got a row at the time. We had to call a method, give me the next row. That method that gives me the next row is very similar to a fetch. And in fact, under the covers, it probably is a fetch, okay? Just let you know that. So this is similar to how PHP works with tables, because PHP, being a procedural language, it doesn't know what to do with a set either. It's got to have a simple variable for each column, and then it gets a row, they fit into the simple variables, and then when it's done doing whatever it's going to do with them, it does another, gets the next row, and that replaces the value in the variables. Cursors work in a similar way, and like I said, I think it's a lot like reading through a file. Okay, here's an example. So I declare a cursor. I called it artist cursor here. I could have just called it artist, or I could have called it Fred, actually. It's a name. A lot of people like to work the word cursor into the names of their cursors because it makes it more obvious what's going on. So I declare some name as a cursor for, and the for is a select statement. So when I use this cursor, I'm also executing this select statement. This select happens to get one column. I could have gotten all sorts of columns, but I'm going to get one column here from a table called artist. You've seen selects, you have your column names, and you have from which table. I've got where clause, right? I'm only going to get particular nationality. Presumably, I've got that nationality into a variable, and so I only want maybe Russian artist, for example. And I'm not going to read the whole table and have an if statement where I say, oh, if the nationality is not Russian, then skip. I'm going to let SQL do that because SQL will do it much faster, okay? So I'm looking for the nationality. And then I have another declaration where I declare something called a handler. And a handler is a special kind of variable that gets set when we get to the end of the table. So I declare something, continue is a name. I could have called it Fred. I could have said declare Fred handler. And the handler is for some condition, the most common condition being not found. And basically what this is saying is when I get to the end, set the variable done to 1, okay? As with many languages, doesn't have a Boolean, right? Java, you're used to having Booleans that hold true and false. A lot of languages don't have that, and we use integers for that instead. So here, our while loop, our Boolean condition in whiles and ifs, if it's 0, a 0 value, that's the same as false. If it's a non-zero value, it's the same as true, okay? We're going to see how this done is used just in a second. So now we come down and we say open and we give it the name of the cursor. We happen to name the cursor artist cursor. When we say open artist cursor, it's going to go out and it's going to execute our select statement. Our select's going to happen, including the where clause and all that. It's going to form a set, might be an empty set, might be a set with one row, might be a set with many rows. We don't know. But the open is going to cause it to execute the select statement that we specified as part of declaring the cursor. If we need several different select statements, we declare several different cursors. Okay? So we open the artist cursor and it does the select for us. Now we get back a set. We've got to go through the set item by item. The way we're going to do that is with a while loop. Okay, while not done. So done starts life as 1. When it becomes not found, when we get to the end, done will become 0. Okay? So while not done, do. So while as long as done has our initial value of 1, we're going to keep going. Eventually we'll get to the end of the table, we'll do a fetch, and the fetch will fail, and the fail will set done to 0, and then we'll fall out of the loop. Okay? So as long as we're in the loop, as long as we have more to read, we'll fetch whatever is in artist cursor into a variable, right? This is like doing a read. This is like doing our next row thing. So we call fetch on the cursor name, and we tell it to put the results into this. Now, why is there only one variable here, right? It's a whole set. Well, because we only picked one column. If my select had several columns in it, I'd need to have several variables here, okay? So this is going to loop through our table, and it's going to keep doing fetches until it gets through the entire set that was returned from the select. You'll notice the dot, dot, dot. Presumably I do something useful there. If I'm not doing something useful there, then this is sort of a failed enterprise, kind of worthless enterprise. Eventually I get through my whole set that was returned from my select. At that point my loop ends, I fall out of my loop, and what do? I close the cursor. That frees resources. Okay? Kind of like closing a file. Okay, so this is how we transition between the world of sets that SQL likes to live in and the world of simple variables and loops and ifs that procedural languages like to deal in. As you can see, it's a bit clumsy, but that's how it is. So we'll go on and look at some more detail in a minute.